Hey everyone, what is going on? It is episode 11, and we are going to continue today with the app we started in episode 10. What I did was I copied episode 10's project folder and renamed the copy episode 11. And we're just going to continue working right through there, building out this application and making it work. So let's get into it. But first, so one thing that's a little different is we're not going to create a new project. I went into my projects and I just right click and copied the episode 10 folder and pasted it. And then I renamed the copy episode 11. So everything that's inside episode 11 is exactly the same as it was last week. So check out episode 10 if you need help setting up the structure. So now that I know that, I'm going to now open a project or solution and navigate over to episode 11 and the API until I see the .solution file. And that's what I'm going to either double click or click once and hit open. All right. And then I'm going to right click the Visual Studio and I'm going to open another instance by clicking Visual Studio again. And we'll open up the web project that is also located in the same place. So open a project or solution in this Visual Studio instance and episode 11. This time we'll go under UI, MVC, and also the solution file will open. All right, so let's pick up where we left off. I'm going to minimize the UI project for now because we're going to continue working in our API. So when we left off, we had a ping controller. We created a models folder. I'll be referencing the website from episode 10 a lot, so if you're not familiar with that, you really should at least skim the episode 10, and I'll also put a link in the description here for the Git repo that has the API site, and I'll add one also for the website. I'll do a separate video on Git just for the basics so you know how to pull stuff and how to put your own code up in your own GitHub, but you should probably start learning how to do that also. All right, so in our project, the main screen brings back a list of products. So we're going to create an endpoint in our API that can return a list of products. And to test that out, we'll be needing Postman again, so I'm going to launch that. And we'll get to that in a little bit, but we'll just leave that running in the background. So for now, we need to make our flow of getting products. So to do that, we're going to start off with a product controller. So I'm going to right click my controllers folder, go to add and choose controller. Just like we did with the ping controller, I'm going to choose API and do an empty API controller. Sorry if there's some noise, if you can hear that in the background. It is storming out pretty good right now. So that's what that rumbling is. It's not that I'm hungry. All right, so our API controller, we're going to highlight the word values and replace that with the word products. And that makes a products controller for us. I'm going to right click and remove and sort usings just to keep things clean. The default get method for my products controller is going to return a list of products. And for now, we'll just make it very generic. So we'll start as if we're just making a regular method. So just public, it's going to return an iAction result, which is our status code of OK and any data that gets returned, just like our ping controller had to do. And this one, we can just call it get. We could name it get products. Because it's a products controller and it's a get method, you can assume that you're getting a list of products. So we really don't have to name this one anything other than get. The way you get to the get method is really controlled by the route attribute anyway. So first we'll put the attribute HTTP GET, and we don't really need any other route here because this route is going to be API/controller in brackets, and the controller in brackets is a symbol that gets replaced with whatever name is here in front of the word controller. So to get to the GET, you would just do an HTTP GET in Postman, and your path would be whatever your host is /API/products in this case, because the controller is called products controller. So I can just put that as a note. So it's whatever your site is. Oops. Whatever your site is would be displayed there with some port. And then it would be /API/products. And then if you do a get to that, it'll just call the get method here. The reason it's red underline is because we're not returning anything, and we told it we were going to return an action result. So I'm just going to return an OK, and that'll return that 200 OK that we looked at last time. So let's test this out, make sure that it works and returns an empty result with a 200 OK. And we should also now see our products controller get in our Swagger documentation. It does take a minute to spin up and render. So here's the products, and we do have an API products. And so I'm going to grab just the part with the port and everything before it, and we'll put that into a new get request for Postman, and we said it was going to be /API/products. And so if I send that, I get a 200 OK, and there's no data here. If we look at the raw that comes back, there's nothing. It just returns the status code. So the next thing we want to do is we want to have our controller call out to a service and have the service do the work. The idea here is that we're splitting up the concerns of each of these classes. So the controller, or in this case, the products controller, its responsibility is to listen for gets that are at API/products. And its job is just to call out and forward that request on, and then any work that gets done outside of this class will get returned to it in some form of a variable or a return type, and we'll just send it back inside the parens of this OK. So we need a line of code before this line to actually call out to do the work, but we don't want to actually put the code for the work in this class, because if everything was in here over time, as you keep adding functionality to your web API, it would get so complicated and hard to maintain that it would be a pain, especially if you're talking about enterprise applications. There are many different patterns and ways to create an API. I'm going to teach first the repository pattern with services. So let's create two folders to implement that service repository pattern. So we'll right-click the project, and we'll do add folder, add new folder. And the first one is going to be called services. And all of our services for this whole project will live in there. And then we'll right-click the project again and add a new folder at the same level. And this one will be called repositories. So what is the job of these two? So the service is kind of like a director of affairs, right? It is the one that's going to get called by our controller, and it will decide which repositories it needs to call out to. It will decide what to do with the data before that data gets returned to our user. Maybe we want to massage that data. We want to filter some things out. Maybe the data that we get back from our repository has information in it that we don't really want to return to our users. Maybe things like the last time that data was updated. Maybe we have some proprietary internal IDs that wouldn't mean anything to our end users, to our API consumers. And so we want to be careful with what the models look like that we return to our users. For now, we're not going to get into that level. We'll get it working first. Because our controller is going to call out to a service, let's create that one first. So I'm going to right-click Services. I'm going to add a class. We'll call this class Products Service. So just by its name, you can kind of tell that the product service is going to work in conjunction with the products controller. That makes things easy to understand at a glance when you're looking at a code structure. So it's a good practice to name things consistently. Our product service needs to return some data. So let's go back to my example program for a minute. We haven't coded this stuff yet, but I wanted to take a look at what was being returned because this is kind of what we're building, right? When we looked at the homepage and saw the list of cards with all the products on it, it was returned as a list of product, and a product is a class with these properties in it. And so I created a new empty list called products, and I just said add a new product that looks like this, add another new product that looks like this, and I just kind of faked the data manually in 9 different products. So I know what a product needs to look like for the website that we're building, and I know that I want to return a list of them. So I'm going to put this off to the side for now. When the products controller returns the product service, it's going to have to call a method. So it's going to be a public method. That method is ultimately going to return a list of a product model. Product, right? It's a single product, but it's a list of them. And the name of this service method is going to be getProducts. So we just end up with a method that we can call from our controller and return a list of products. So for now, I'm just going to throw a new not implemented exception. So if we actually call this method, it's just going to blow up and give an error. But it also doesn't complain that I'm not returning anything because it's going to throw an exception. The red underline here is underlined because we don't have a product model. We haven't defined it yet. So let's go ahead and do that. I'm going to right-click my models folder, and I'm going to make a new folder inside models. And for now, I'm just going to name it API. These are going to be the models that get returned to whoever calls this API. In our case, we're just going to be using Postman, but ultimately that product API model is the one that's going to be returned to the website. So inside our API folder, I'm going to add another class. And this class is just going to be called product. And I'm going to just make a quick copy of what this product looks like. And oops, there we go. And so this syntax, by the way, the /**/ is the way we can do a block comment without it putting // in front of each line. But it works the same as doing that. So if you wanted to do it the other way, you could. I just put that there so that I could reference it when I say prop tab tab. The first number is an int, and it's called ID. Hit enter, and now I need title, description, image, location, and price. So that's 5 more properties. So I can control D, 1, 2, 3, 4, 5. And I'm just going to copy and paste the names. And now I have to change the data types. The ID is an int, title is a string, because it holds a title, a description is a string, the image is a path, which is a string, location is just a string, and the price is a decimal. All right, so now I don't need this anymore. I can erase that, and I've got my class that looks like the object that I want to return. Now I can bring in the namespace for this product. And if you hover like me and you're not getting your little light bulb so that you can auto add the using statement, you can right click and force the light bulb to pop up. And now it says add the using for Noble Cause, Savage Cell API, Models API. And that is my product. All right. And we will sort and remove. Notice it also added a using for system collections generic. That's because we have this generic list. We covered that in an earlier episode. All right, so if we go back to our products controller, we can call this get products. So one way to do that would be to create a variable called product service. And it would equal a new product service. And then we could call product service dot get products. And we, of course, need to bring in the namespace for our product service. Oh, I misspelled it. That's why it doesn't see it. I called this one products service, and then I typed product service. So let's rename that guy. And now we'll have to bring in the namespace, right? It lives under API services. And let's rename this one too. To rename this one, I'm going to do a Control RR, which is the same as right-clicking and doing rename. You can see Control RR there. And what that'll do is it will rename this not as a word, but as a C# symbol. And what that means is anywhere else that I've used this variable, it'll rename that one too. So if I just do Control RR and I add my S in here, when I hit enter, notice it also updated this one for me. Okay, so this will create a product service and call get products, and I could just store the result of that. And if I looked at var here, it tells me that it is a list of T, and that T in this case is a models.api.product. So it is a list of product, and I could take that variable and return it inside my OK. But this is not the way that we do things. So that brings us to our next subject, which is what you need to know right now about dependency injection. With dependency injection, we create an interface. We inject those interfaces into our classes so that we can change them out later. Why would you want to change them out later? Well, when we write code, we also try to always write unit tests for our code to make sure that our code does what it's supposed to do. And if we have a test that tests that code, then if somebody else comes in later and makes a change, maybe an enhancement, and accidentally breaks the original functionality of the code, then we want that test to fail so that that new developer, even if that developer is me, we want to know, hey, you broke something. Even though you added this enhancement, you inadvertently made a change that you probably shouldn't. Or maybe you need to update the test if it's working as it should, and the test should now pass anyway. So in the case of testing this method get, we really want to make sure that we can navigate to get, that we can call get, and that we get an expected list of products back. We don't necessarily want to call the real product service and have it go out to a database, or maybe we're saving some data. If we later on do another method here to add an item, we might have a post. And if we're adding an item, if we're trying to test that code, we don't want to add a test item, a fake item to our system every time we just run a unit test. We would quickly end up with garbage in our database that we really don't want there. So we need a good way to fake or mock this product service later. So if I'm declaring this as a new product service inside Get, I don't have a way from outside of here in a unit test project to replace this product service with a fake service later. So what we do is we create an interface for our service, and then we have .NET inject our product service for us. And when we're using a unit test, we manually will put a fake product service in there to make sure it doesn't actually make the calls that the real product service does. Okay, so how do we do all that craziness? It's not that bad. So first thing we're going to do is we need an interface that our product service adheres to. And an interface is kind of like a contract, something that our product service has to look like. So I'm going to right-click my services folder, and I'm going to choose class. And even though I chose class, if you notice, there's an interface right below class. Interfaces are generally named starting with a capital I in C# at least. And so I'm going to name this one I products service. I'm going to make it public. Now in C# interfaces, notice it says interface here, not class. We can define our methods, but we don't put a method body in it. So in our case, we want our product service to have a public list of product, get products. And then we just end it with a semicolon, and it still needs the product namespace added. So we will hover it and choose to add this using, and I'll clean those up. All this says is if you want to be an iProduct service, then you must implement a method called getProducts that returns a list of product. Well, our service already does that. We already have a getProducts method that returns a list of product, right? We just wrote that. So in order to make this product implement that interface, we put a colon here and we add the name of the interface there. So what we're saying is the product service implements iProduct service. And to prove that, I'm going to delete this for a second. And it'll show you now that you can't compile anymore. And the reason is product service does not implement interface member iProductService.getProducts. Because iProduct service defines what it is to be an iProduct service, which in this case is just a method with a list, I can hover this and go to the light bulb menu and tell it, implement this interface, create the minimum requirements, and it will add the method for me. So if I define my interface first, I can have it add all of this code in for me to make it a compliant service. Now, it won't know what to do inside of getProducts, which is fine. We'll fill that in. But it does at least know that I need to have this and a body with something in it in order to be an iProduct service. Hopefully that's clear. So next, what we want to do is go into our products controller. And what we want to do is we want to tell it, hey, when you construct one of these products controllers, I want .NET Core to inject one of these services for me. I just want to be able to use it from inside the products controller. I don't want to be responsible for creating new ones because I have to mock them later for unit tests anyway, and there could be other reasons that I may want to replace this service with another service at some point anyhow. All right, so let's get to work on injecting this product service. The first thing we need to do is we need a variable to hold our service. So I'm going to make a private read-only iProduct service. I always miss that S. Maybe I should have named it without the S. And then I'm going to name that underscore products service. And so the underscore just usually is a naming convention we use for private class level fields. And read-only is something that we haven't covered in these lessons before. All that means is I can only set the value for this in the constructor for this controller. Once construction of this object is done, this variable becomes read-only. You can't change it. So it's safer to mark it read-only so that once the product service is injected, nothing can mess with it by accident. And the next thing we need is a constructor. There's 3 ways to do this. The first way is to type everything out. Not a fan. The second way is to use a snippet by just typing CTOR, which is short for constructor, and hitting tab twice, and it makes a products controller. And then I could put in the iProduct service, and then I could assign the variable to the field in here. I'm not going to do that either, because I can just click into my variable field here, the name, and then if I go into the quick actions, one of the things in there is generate a constructor for me with the iProduct service. That's what I want. So now it created a constructor. So in order to create a products controller, we have to pass in an iProduct service, and we'll assign that iProduct service to our variable. And then inside here, we can get rid of our new, right? We don't have to do that anymore. And we're going to just use this variable in place of our previous product service. So this should make mostly sense right now, but it still won't work yet. Can you see why? The reason is, what's calling this? What's passing in a new product service class and allowing me to use that instance of that class to call get products? Something has to create my products controller and pass this in. And this is where dependency injection comes in. We're taking away the responsibility of us creating a product service, and we're going to hand it off to the project and to the .NET Core infrastructure. So we do that in the startup class. Let's take a look now at how this is going to get injected. And to do that, we have to understand a little bit how this whole program bootstraps. When I click Start up here, what happens? Well, we have a program CS, just like we did in our console app. Except this time in our static void main, the template that built this whole project gave us a create host builder, and then it does a build, and then it does a run. Create host builder is just a method that it's calling right here. And it calls create default builder. And the default builder will eventually call configure web host defaults. And when that gets called, it's going to call the startup class. And that's what this use startup just says. Hey, after we start, run this class. And you don't have to remember any of this. You don't have to know any of this. We're not even going to probably come back to this file again. But I just wanted to show that it's not magic. This thing just magically runs. No, it calls main and it runs a bunch of built-in methods that are part of the .NET Core subsystem. All right, so use startup calls startup. Let's look at this startup class in startup CS. In here, we will make some modifications. So it's just a regular class. There's nothing special about startup other than the name. And when startup gets called, it actually uses its own dependency injection to inject config files. And we'll check those out later as we get into making settings and things configurable. So it sets this configuration object into this read-only property. And then it's going to call configure services. It even says this method gets called by the runtime. So you can add any code in here and it will run it. So what is it doing now? It's adding all of our controllers in so that we can use the controllers and that the controllers are available for listening. It adds a service for Swagger so that we get our Swagger documentation. And then the runtime also calls configure, and it does some things for us, like if the environment is development mode, meaning we're debugging and running here inside Visual Studio, and it's not a deployed website somewhere, that we do some other things like use the developer exception page instead of the regular there was an error page. Give us more details because we're developing right now. Use Swagger and show me that Swagger documentation. We may not want that to be exposed to the public when we're not developing. Maybe we do. And there's some other things in here. All right. What we want to do is go into the configure services, and after this Swagger generation line, we want to tell services that we want to add a singleton. The type of singleton that we want to add is an I products service interface, and we want it to create a products service. And then if we bring in the namespace by right-clicking and doing our using, now it's happy with this line. If I would have spelled this correctly. Products service. There we go. Okay. See, typos are okay. All right, so what is a singleton? A singleton is just one instance of this object. What it means is it may have to call a bunch of different things in our code. We may use this product service in many controllers. But if we do, it'll always be the same instance of that. It won't create a new one every single time. And that's okay for us because right now, if you look at our product service, it doesn't do anything with like private variables that it has to track in between calls. It's completely stateless, and it's going to do the same thing every time we call it anyway, independent of who calls it. So a singleton is actually really good for us in that it won't create a bunch of instances and take up a bunch of memory that we don't need to consume. If we didn't want a singleton, there are other adds that we can use, and we'll probably get into those later on. But let's leave this one at that. So by adding this singleton to our services, what we're telling it is, hey, when you're constructing everything and you're adding your controllers, if you see any controllers or any classes really that you are responsible for creating, and those classes have a constructor that takes in an iProduct service, pass in this product service class. We want this one here to get created and passed in. Just in case there's more than one, this is the one we want. This is the implementation that we're planning on using. And so when it sees the products controller with a constructor that takes an iProduct service, it says, oh, I know what to do with that. I'll create a new products controller and I'll pass in a new product service, but I'll keep that instance around in case I have to create another product controller later. I can pass the same one in. Or if there's another thing down the line here, if the services maybe has some other, if I call multiple services and that service needs a product service, I only will have one that I'm going to pass around. So now, after this thing gets created, the product service is a real product service class, and we'll call get products and return the products and pass it back to OK. If we do that now, it's going to blow up because our product service just throws an exception. So let's change that. What we're going to do is we're going to have our product service call our products repository. Remember, the product service is only responsible for dealing with massaging any data before it goes back to the controller, and it calls out to another class whose responsibility is to get the data. So I'm going to right-click the repository. I'm going to add a new class. I'm going to choose interface because I know that I'm going to inject this as well so that I can test my service later. And I'm going to name this one products repository. And just as a shortcut, I'm going to copy everything except, I'm going to copy everything except the I. So I'm just going to copy the word products repository and I'm going to click add, but it's going to create an interface called iProducts repository. I'll show you why I copied the word products repository. So first thing is we got to make it public. And I can tell you right now that I know my service is going to have to call out to get products. So I'm going to go ahead and make a public list of product. And I'm going to also call it get products. And now I'll just bring in the namespace for product. And there's my product repository interface. Now I need a class. So I'm going to right-click repositories to make the actual instance class. And I'm going to just hit paste. This is why I copied it earlier. I need a class called products repository. And now I need to make this repository implement that interface. So I'm going to type colon and I'm going to paste again because it needs a iProducts repository implementation. Remember last time when I said we can define what we need in our interface? Then we can just go to our product, hover, select implement interface, and we've got our get products method. So instead of throwing a not implemented exception, let's just return a new list of product. It'll be empty, but it'll be a real instance of an object. Makes sense? So now we have to go back to our service and have the service call the repository, but I don't have a repository. Well, since I'm going to need unit tests for this method later, let's create a variable to hold our repository. And it's going to be an iProducts repository called, products. I knew I spelled that wrong. Repository. And we'll make that read-only as well. And I'll add the namespace here. And I'm also going to just click in here and tell it to generate the constructor. Boom, just like last time. So now instead of throwing not implemented, let's implement it. I want this method to return the result of the products repository dot get products. So let's follow this through from the beginning. Our products controller injects the product service so we can use it later. When something navigates to API products, it calls this get method if it's called with a get, and it calls our product service.getProducts. Product service.getProducts is using a products repository, which is injected into it, and it calls the repositories get products. The repositories get products doesn't have anything injected in it now, and it just returns a new list of product. So this list is going to get returned back to the service, which immediately returns it back to the caller, which is the controller, which will put an empty list of product in products, and we'll return an OK with products. In fact, we can put just this part of the code in place of here, but I want to step through this at some point. So for now, I'm going to leave this as a variable so it's easier for us to demonstrate. So let's run that. Oh, it's going to blow up. We forgot, and by we, I mean me. Hopefully you're screaming at the video right now and saying, Jeff, you forgot something. So what did I forget? I created a products repository that gets injected to the service, but I never added it to the startup to dependency injected. So I'm just going to duplicate this line with Control D, and I'm going to tell it that, let me add the namespace using. All right. So I'm saying that if you see anything that needs construction with a repository, create one of these products repositories and pass it in. So now that will take care of the service class. And because we're constructing this controller and the controller needs a product, dependency injection will automatically look at what dependencies the product service needs. In this case, it needs an iProduct repository. It will construct one of those, which doesn't take anything. It's just using the default constructor, so dependency injection would have nothing to do at this level. So now let's run it. And once we see that, we'll go back to Postman and just hit send again. And now not only do we get a 200 OK, but we're getting empty square brackets, which shows an array. So that's our list. In JSON, the brackets are an array. So far, so good. Now I'm going to go back to my example here, and I'm going to copy just this beginning part. So instead of returning just an empty new list of product, I'm going to paste the code in from my other site that is slightly farther ahead than we are. And I'm going to create a variable that holds that new list of product. And then I'm going to do a products.add, and I'm going to set up our new product with these values for these properties. Now, one thing we're missing here is our lorem ipsum generator that we covered in a previous video. So let's go ahead and NuGet those in so that works. So if you remember, we right-click. Well, let me copy lorem.net core so I don't have to type it. I'm going to right-click dependencies, and I'm going to manage NuGet package, NuGet packages. I'm going to go to the Browse tab, and I'm going to search for that lorem.net core. Select it and hit install. I agree to any agreements that are needed, and I can close this. So get products is still complaining because we're not returning any values. So after we create our list and add an item to it, we need to return the products back to whoever called it. So now if I run this, instead of returning an empty list to the service, the repository is going to create a list with a hard-coded value. And if we go to Postman once that's running and hit send, now we see our JSON object back. We get an array with one element in it. I'm going to now add the rest of those 9 products below this one. Now we will return the same list, but it'll have all 9 things in it. Let's run that. It might not be ready yet. Oh, there we go. Okay, 200 OK, and I get back all of my objects. So that's it for this episode. I hope that was really good stuff. We took a basically empty web API and we added the repository and services to it. We covered some simple dependency injection, and we added some hard-coded products to our list. In the next episode, we're going to take this list of products and we're going to load it into our website, and we're going to show how the website connects to the API, gets back this list just like Postman did, and then use that to display products on a web page. And then we'll start styling some things up and take the API even further. And in future episodes, we'll go ahead and replace this hard-coded stuff with some actual database access that loads dynamically from a products table in a database. So let me know if you have any questions. As always, practice, practice, practice. And you know what? I'll see you online.